Make sure you go ahead and get this written down. It's the beginning of our notes for the next section, which is 6.3.2. We're still doing elimination. That hasn't changed. The question might become a teensy bit more complicated, though. So if we take a look at this system, I do my quick inspection again. It's definitely set up for elimination because everything is stacked up. X's, Y's equals constants. I always try adding straight down first. If I add straight down, the X's turn into a negative 24. That's not a 0. That doesn't do me any good. If I check the Y's, if I add straight down, that gives me an 11. That doesn't do me any good. Okay, so the next thing that I would check, because adding doesn't work, is maybe if I just flip the signs on one of them. All right, so if I multiplied by negative 1. Well, if I look at the X's, the 8 and the 16 are not the same number. So even if you flip the sign, it's not going to work. 4 and 7, not the same number. So even if you flip the sign, it's not going to work. Ultimately, at this point, and actually it's like this every time, you guys need to choose. But I want to talk about what the options actually look like. So here we choose which variable to eliminate. Now, ultimately, over the years, I've had students say, I am always going to eliminate X, no matter what. Okay, that's totally fine. It's ultimately up to you. I have some people say, no matter what, I'm solving for Y. Okay, that's fine too. It's ultimately your decision. I have other students over the years who say, I'm looking for the easiest way possible. Okay, those are my people. I like looking for the easiest way possible. So I want us to take a look at, well, what would happen if we chose to eliminate X versus if we choose to eliminate Y? And then you decide. So let's say if we eliminate X, I'm going to bring down my system. I've got negative 8X plus 4Y equals 12. And then negative 16X plus 7Y is equal to 21. Okay, if I'm eliminating X, I am only looking at the X's. My first question, or first thought as I'm going through this, I've already gotten rid of the possibilities of adding doesn't work, flipping the sign doesn't work, okay? But I want you to think back. If we are allowed to multiply by a negative 1 all the way through an equation, we can multiply by anything, folks. Anything we want. So I guess my question is it possible to make the negative 8 and the negative 16 the exact same number with multiplication? And the answer is yes, for sure. With multiplication, as long as one of the numbers isn't 0, I can match any number at all. Some might require a little bit more work, some might require a little bit less. So, could I make a match? Sure. All right, path of least resistance. Take a look at the smaller number, which in this case is the 8. Can I turn the 8 into the bigger number? Yes, I think I can.
Can I say it for you?
Absolutely.
You multiply by -2?
Yes. Because I want them to both be 16, but I want the signs to be different. So I think we can take this entire first equation and times it all the way through by -2. Now, I'm not going to do it yet because I don't know if I want to eliminate x or y. Remember, we're trying to determine which way you would choose. So ultimately, it's your decision. So let's take a look at both options and see which one you'd prefer. But that's all I would have to do. Multiply through by -2 and then add straight down, and it works. Let's take a look at what happens if we eliminate y. And I'm not saying there's one better way over the other. It's a personal preference. All right, well, let's play around with the system again. So let's bring this down. -8x plus 4y equals 12. -16x plus 7y is equal to 21. Okay, only looking at the y's this time, only. Same idea. Could I make the 4 and 7 match? Of course I can. I always can. All right. Could I take the smaller number and with multiplication, turn it into the bigger number? So 4 times something gives me 7. The answer is yes, folks, but I do not want to do that because it's going to be a fraction. I don't want to make this worse on myself than I have to. So could I turn 4 into 7 with multiplication? Uh-huh. Do I want to? No way. So maybe I need to get both of them to match the same number. So let's think about that. I have a 4 and I have a 7. What I want to imagine, now this isn't necessarily something that you have to write down, but I want to take you through my thought process so you can see, well, where on earth did she come up with those numbers? I think about all of the multiples of 4. For example, 4, 8, 12, all the numbers 4 goes into evenly. So like 4 times 1 gives me 4. 4 times 2 gives me 8. 4 times 3 gives me 12. 4 times 4 gives me 16. And so on. I'm going to start doing the same thing with 7. 7 times 1 is 7. 7 times 2 is 14. I'm doing this because I'm trying to find a number that's in both of the lists. That means that I could turn both of them into easily. Well, if I go through this, I think the first number that I could turn them both into is 28. So now I could turn both of them into 28. Well, one of them into a positive 28, one of them into a negative 28. If you have the 4, to get 28, we're going to have to times by 7. So the entire first equation is going to have to be times by 7 to get the 28. If I have a 7, well, I'm going to have to times by 4. So the entire second equation would have to be times by 4. But even then, they'd both be a positive 28. I don't want that. I need the signs to be different. So one of these, doesn't matter which one, you'd have to multiply through with a negative. So I can make it work. Doesn't matter if I'm eliminating x's or y's. But take a look at it. Take a look at your two options. We've got the option to eliminate x over here, where all we need to do is multiply one of the equations by -2. Then we've got our other option to eliminate y, where we'd have to multiply both of the equations. They'll both work. Now, I know you guys know me well enough by now. I am not a big fan of doing more work than I have to, at all. And it's not because I'm lazy. It's because I know the more extra work I have to do to solve something, the more opportunities I have to make a mistake. And I'm not talking about you. I'm talking about me. I know the more extra stuff are more chances for me to make a mistake. So I don't want to do y. I do not want to do that method. I could. It'll work. I just prefer not to. So I'm going to go back to the eliminate x part, and let's solve it this way. So now let's actually do it. So we're going to distribute that -2 all the way through. That's going to give me a positive 16x, a negative 8y, and a negative 24. So all the way through. Slide the other equation over. Now, if we add straight down, the x's will eliminate because they have the same number, opposite signs. Now we add straight down. I want you guys see if you can solve for y. We know we got to solve for x, but let's make sure we get y correct first. Okay, adding straight down, the x's go away. We get a negative 1y equals negative 3. Divide by the negative 1. Those cancel. Looks like we get y is equal to positive 3. So that is half of the answer. Remember, go back to the original equations. Don't use one of the ones that you changed. Go back to the beginning and plug in what you found. I think I'm going to use the first one. Not that it matters. So negative 8x plus 4y equals 12. Be careful that you plug it in where you solve what you solved for. So negative 8x plus 4, open the parentheses, equals 12. Now in the parentheses, cram in what you found. And now we solve. 4 times 3 is 12. Let's draw that line, since we're now going to start moving things back and forth. Minus the 12, that cancels. Negative 8x. Okay, 12 minus 12 is 0. This is fine. Keep going. The only time we worry about no solution or infinite solutions is when the variables just disappear. So divide by negative 8. If you have 0 in the top of a fraction, it's actually kind of nice. The answer is just 0. Okay, from here, write it as a point. So we have our solution written as 0, 3. So here, what I'd like you to do, take a look at the equation. Run through the list of questions. Is it set up for elimination? If it's set up for elimination, can I just add straight down? If I can't add straight down, could I just multiply by negative 1 and then add straight down? All right, if that doesn't work, what do you want to eliminate? It's your choice. You choose. So after inspecting this, just kind of make your decision. Make a little note to yourself. So I'm going to eliminate x. All right, to do that, I'm just looking at the x's. I can turn the 7 into the 35. Definitely. I think if I multiply by 5, I can turn it into it. But if I multiply by 5, then they'll both be negative 35x. I don't want that. I need to flip the sign as well. So I'm going to multiply by -5 all the way through. All right, if we do that, that's going to give me a positive 35x, a negative 10y, and a positive 30. All right, let's slide everybody else over. So I got a negative 35x plus 10y equals negative 30. Okay, this looks interesting. If I add straight down, everything disappears. I get a 0, another 0, an equal sign, and a 0. All right. Whenever the variables completely disappear, you have to ask yourself the one single question. True or false? That will dictate how we answer this thing. So, do a quick check. Does 0 equal 0? Yes, definitely. 0 doesn't equal anything else except for 0. This is true. If this is a true statement, then our answer is infinite solutions. If it was false, then we would say no solution. If it's true, that means it doesn't matter what points you plug in, it's going to work. If we graphed it, these two lines, it wouldn't even look like two lines. It would look like one line completely. Okay, let's try another one. So here we go with question number 3. I want you to inspect this. And answer the questions for yourself. Set up for elimination. Okay. Can I add? Well, if that doesn't work, could I just flip the signs? Well, if that doesn't work, all right, choose. So give this one a shot. Make a decision first on what you're going to eliminate, and then let's see if we can figure out what you're going to have to multiply to make that happen. So if we want to eliminate the x, I'm going to make that little note to myself over here. Only looking at the x's, I've got a 5 and a 4. I think the smallest number I could turn both of them into is 20. So to get a 20 on the first one, I've got a 5. To get the 20, I'm going to multiply by 4. On the second one, I've got a 4. To get the 20, I'm going to need a 5. Now, do I have to multiply by a negative sign, or are the signs already opposite each other right now? Yeah, they're already opposite. I'm good. So now, let's distribute. So that's going to give me a negative 20x. Remember to go all the way through the equation. Plus 40y equals 80. All the way through. 5 times 4 is 20x. Minus 30y. I think that's a negative 70 when I multiply the 5 and the negative 14. Quick check. Yes, if I add straight down now, my x's will disappear. So those are gone. 40 plus negative 30 is 10y. 80 plus negative 70 is also 10. Oh, this is kind of nice. Divide by 10. I think we just get y equals 1. Go back to the original questions before you did anything. Choose the one you prefer. I don't know. I think I'm going to go with the second one. Not that it matters, though. So I copied down the second original equation before I did anything to it. I solved for y, so make sure that you plug it in for y. So it's 4x minus 6, okay? Let's create a hole there, equals negative 14. Now plug the 1 in. All right, let's draw our line and solve this thing. So that's going to give me 4x minus 6 equals negative 14. Move the 6 to the other side. Those cancel. Drop the 4x down. I think that gives us negative 8. Okay, this actually works out pretty nice. Looks like y, whoa, that's not true. X is equal to negative 2. I have both of them now. Remember to write it as a point. Our solution, alphabetic order, x first, then y. I believe that that is our answer to this one. So here's our last one. Give it a shot. I want you to do the entire thing all the way through. Run through the questions. Is it elimination? Is it stacked up? Can I add? Do I have to multiply by negative 1? Do I have to multiply by more than that? So you decide.